Hey, how's it going all? I just want to do a video on a test that I thought of that I would need to validate gravity. And so broadly speaking, this is to answer a question about what it would take for me to acknowledge, that we live on a ball or to believe that we live on a ball. And so most flat earthers would be like, just show me an image, non-CGI, zooming in and out, buildings upside down, people walking around, all that kind of stuff. That would be obviously more than enough. That's perfect. Assuming that we don't have access to that at an individual level, in our lifetime. The next thing that I would consider rigorous is like an image of showing buildings tilting relative to one another. That to me is conclusive. And, there should be lots of examples of that if it were possible to do it once, to see many of them. And then, so let's say, and I want to explore that more, like look into ultra wide angle lenses and all that kind of stuff. But let's put that aside. I thought of something a little bit kind of crude, but possible, and if it's not actually done, as an experiment, it's definitely a good, thought experiment for both sides to kind of think about. So let's take a look and see if gravity is real. And so this is what would be needed to conduct this test. Would be 3 humans. They would need to have strong shoulders, and I'll explain why. 1 human, another one, to do the recording of this, capturing the results, following it along. 3 flat pieces of wood. The length is arbitrary as long as they're perfectly flat. So a level run across all 3 of them would read a flat output. And 2 carpenter's levels and patience and endurance. And I'll explain why patience and endurance will be needed. So this is the beginning of the experiment. And so I'll explain that there probably could be a much easier way to do it and less laborious. But let's start with 3 humans just for the sake of understanding the test. You have 3 people holding up, their piece of wood, and then you have 2 carpenter's levels at the interface of the pieces of wood. And so they would all need to hold them up to read, level for both of those carpenter levels, and then that would be kind of the beginning point of this test. This is the starting point. And so, assuming that these are real people and then they're holding up, reasonably like a relatively small size of wood, the gravity vectors acting on both of those levels would be essentially the same. They would be microscopically different in orientation, but so that would explain why both of them are reading the same thing, even though they are not in the same position in 3-dimensional space. But this is our setup, and so the important thing is that you have these 3 pieces of wood. They're contiguous, and that the level is red level at the beginning, and then so someone would document this with a video or a picture or whatever. And so here's where the test sort of starts. And so we would then take the person on the far left and then move them to the front. And so in like real life, this would be 3 people who are just moving, and it could be in any direction. It doesn't matter if they face an obstacle and they need to turn and all that. The most important thing is that wherever there's a direction change or whatever, is just that the level reads level at the interface of the pieces of wood. And so in this case, the person moves to the front, takes the level with them, and so they're at the front now, and they're experiencing a new gravity vector at, let's say, position 2. And so again, if it's only one iteration, we wouldn't expect anything different for the reading, because they're all fairly they're in a similar position in 3-dimensional space, that we would not think that the gravity vectors acting on them would be appreciably different at this point. But if you kind of get the drift of this, is that if we do it enough, and essentially we keep moving the person from the back to the front, and then putting the level at the interface, and then recording it that it's always level. If we did this enough and then moved a far enough distance away from gravity vector position 0, Baller theory states that the level, even though it's resting on a flat surface, would have to start reacting, just simply because it is experiencing a gravity vector in a different orientation than gravity vector 0. And so, to make this less laborious, we could use drones, just throwing it out there in case, a baller gets ambitious and wants to do this to prove to us that gravity is real. And then so, they're there could be a way to use technology to make this test simpler. But the nice thing about this experiment is that it lifts the test kind of off the ground. There's no like perspective. There's no any kind of thing that's subjective. It's just strictly you have to move far enough away in any direction in three-dimensional space from the original gravity vector position 0. And once you're far enough away, another gravity vector, which is pointing perpendicular to the surface of the Earth, would need to start interacting with that level and causing it to shift. And so this is visually what's happening, is that if our first position, the beginning of this experiment, is at gravity vector position 0, and then we see that that piece of wood is represented there, that's the wooden plank's motion or position in space. It's like it's essentially, this test is basically just to create a really, really long piece of wood. Like, obviously we don't have like a 5-mile long perfectly flat plank, and then but in an ideal, let's just say we did have access to that and we could hold it up in space, however it's suspended in air. Baller theory says that if you rub a level across it, eventually it would start moving. Once it starts interacting with a gravity vector that is appreciably different in orientation than the vector that the level was interacting with at the beginning of the experiment. And so this, to me, if this were to happen, to me, this is absolutely rigorous. This is exactly what we would expect these gravity vectors to do. The only thing that is up for debate is how far one would need to go to experience enough of an orientation change in the gravity vectors to get it to come alive, so to speak. And so that's the part that I'll leave open for anybody who has the ambition to conduct this kind of a test. But for us flat earthers, this is more of a thought experiment to kind of reaffirm the fact that, in my opinion, gravity will not be there to save the day. You rub a carpenter level, these two across those 3 planks, you can go for forever. As far as you can go, hit the ice wall, it's still going to keep reading flat. So let's talk about these Freemason vectors. So Baller theory says that if this train of 3 people or drones with 3 flat pieces of wood would do this for a far enough distance in any direction or in any change of direction, the level would spontaneously start moving once it interacts with a G vector whose orientation changes appreciably to the original vector acting on the levels during the first iteration. So all that is reaffirming is this picture, is that if we do our part and keep the reference plane flat, eventually gravity has to do its part. And basically, if you think of what gravity will do, is that it's taking an inner product of its orientation with the level. And if that inner product is 90 degrees, then it's going to show level. And so if we are keeping, if we're keeping one of the axes constant, and the only thing that's changing is the direction of the gravity vector, then if this is the way that gravity works, then the level would need to react. And so if the level is truly interacting with gravity vectors, then it would need to acknowledge the fact that it is no longer perpendicular to, in this case, gravity vector position _n. And so, we're doing our part. We're keeping our axis, consistent through drones or through humans with really strong shoulders. And then so gravity now needs to do its part when it is no longer perpendicular to the level. And so if anybody shows me this test on video, I suspect many others will become a baller. To me, this is rigorous. If this happens, this is a phenomena that can only be explained by gravity. If you have 2 levels that are moving across a flat surface, like these planks that are just, reorienting themselves with every iteration of the test, but still remaining flat, that's only the only thing that's doing that is gravity. It's not the environment. It's not anything else, because, like I said, we're only going to the next iteration once, the both the levels read flat. And then so we've done our part in keeping the axis fixed and in the exact same direction. And so if someone does this, I will start a GoFundMe to pay the group that does this, and I will seed the fund with a donation of $1,000 USD. And so eventually the levels would need to start moving. I can't tell you what distance it will. I think that's the not so much subjective, but it has to do with the tolerances of the level and all that kind of stuff. But eventually, it would need to start moving, and so that this to me would be more than enough, and they don't have to do it for many iterations, but eventually at some point, once the level is far enough away from its original, where the test began, like I said, it would be interacting with a different G vector, and then it would need to start moving around, even though it's resting on a flat surface. And so not only the monetary benefit, I will delete all the flat earth material on my YouTube channel, and I won't revisit this because to me this is rigorous. If someone were to show me that, I can't argue that. That's what it is. Gravity is real. That's the only thing that any reasonable person would say is causing the level to spontaneously start moving when it's resting on a flat surface. That is the only, we're isolating gravity in this experiment, or at least for now, this thought experiment. And so, to me, that the Earth is a ball. If gravity exists, the Earth is not flat. I don't see any explanation for, there's no way to reconcile this truth, if this actually ends up happening, because that gravity would be doing exactly what the ballers say, is that, being responsible for keeping things in place perpendicular, acting perpendicular to the surface of the Earth. And so in order for that to be true, it cannot be a flat surface, because if you go enough far away and then the level starts moving, that gravity vector would no longer be of the same orientation at the starting point, pointing downwards, on a flat surface. So both of the vectors cannot be pointing down on a flat surface if at some point down the road the level starts moving. So those two gravity vectors would have to be in a different orientation. So that in and of itself to me is rigorous, that it cannot be a flat surface. And so that's this would be more than enough for me. And so if that's true, to me, gravity real, comes alive. It's proven. And then like I've said in other videos, the Bible also gets thrown out. So what I will do, not only will I delete all my flat earth material, I will then become, a person who honestly goes out and ridicules people who follow the Bible, because I've posted, a few videos, and other people now are kind of connected the dots that the Bible is very much a flat earth book. And so, I will point out how they need to throw the whole thing away. I mean, if it gets the shape of the Earth wrong, that's a pretty fundamental thing. And so, that's more than enough for me personally, and I think it should be for everybody to dismiss it. And I think, like I've said before, not just Christianity, Islam and Judaism are not too far behind getting dismissed. And so there's a lot on the table. To me, this experiment, whether it's done or not, is rigorous. I've been accused of asking for stuff that is unreasonable, and that's fair. Like, we're not controlling NASA, even though we pay for it to get the images that we would want, that would satisfy us on what the shape is. I don't make cameras myself, so I can't make up an ultra wide angle lens. I don't have that ability. And then to get enough, separation between two buildings to show the tilt, fair enough. But this is reasonable. I'm not saying it's easy. It's obviously arduous to do something like this, especially if people are involved. But, with drones and different things we have access to, something like this to me is not unreasonable. And we wouldn't have to go for hundreds and hundreds of miles. This would be something, reasonable, in my opinion, that we could do. And, you don't necessarily have to have a clear path. You just have to be able to continue to move anywhere in any direction, as long as you're, like I said, away from the original, the starting point of the test. So, I put this out there as a test, or in the very least, a thought experiment. This is what I would need to acknowledge that gravity is real, and the implications are severe for sure. But I would be humble. I wouldn't. You can't argue with this. It's real. There would be a real thing happening. This would be the phenomena, the effect of gravity that could not be explained any other way. And I will humbly admit defeat. And I have a feeling a lot of flat earthers will as well. The ones, the honest ones. And we would recognize that gravity is real, and what the implications of that are. that the Earth is a ball. And so I put that out there, and hope everyone's doing well, and take care. Bye.